Okay, let's start. Good morning to all of you. Let's start new chapter today. Physics. So you are getting my screen. Let's see. Let me see this. Okay. So let's start. So you know today's the topic is we are going to start geometrical optics. Are you getting my voice? You all?
Yes, sir.
Okay. So the topic today that we have to discuss, that is geometrical optics. Whether you have studied this topic previously or not? Not at all.
Yes, sir.
Okay. So let's start. In optics, there are two branches. One is geometrical optics, and other that is called wave optics. So today the topic we will discuss, that is called geometrical optics. So let me give it a geometrical optics. Optics. Okay. In this topic, as far you all know that we will discuss about light, right? We have to discuss about light. So, what light plays the role? So, there are means if the light is there, then only we can see anything in this universe, right? So, what is the actual definition of the light? You can see, you see over here that actually before this, initially Newton and Huygens already described about light in detail. Huygens was the most senior to Newton, and he said first that light has a wave nature. And later on, Newton, by using the concept of mechanics, he said that light travels in a straight line. That's also somehow true, but the arguments started till the Maxwell. So Maxwell was the only who described the light properly. And according to Maxwell, the light is a electromagnetic nature, means electromagnetic waves like this. Or later on, Planck according to Maxwell Planck, that we say, by Maxwell. So, by the we will discuss in modern physics also. Max Planck's constant, you have already learned small h, that is. So, according to Maxwell, so if you draw a wave, any of the wave in first hit, that is the impression about wave here in mind is this one, like this one. Let's see. This one. So what happened about this wave? This one is called amplitude. This length is called amplitude, right? And here, when you go like this way also, the distance between these two crests and troughs, that is lambda, wavelength. This is amplitude, right? And with the help of this, some frequencies also there. Some of them are beyond visible, and some of them are frequency which is less than visible light, right? So these are called ultraviolet, and here infrared, like this, infrared, and these are the lights. So these are the electromagnetic waves, you can say. We will discuss in detail uh, after electric and magnetic vectors completing this. Okay. So the behavior of light and other electromagnetic waves, these all we deal in this chapter. And in this chapter, we will discuss also telescopes, microscopes, cameras, eyeglass, human eyes, and etc. Right? And also we find in this topic we will discuss this one, holograms, optical computers, and all the which is new techniques in medical imaging. Is okay. So this we will go for in this optical optics branch. Is go like this way. That is concept of called diffraction. The other phenomena are there of light as the reflection, interference, diffraction. We will discuss one by one each and every in different topics. So first of all, let we start, which is not the part of JEE syllabus. So I am ignoring this all, and let's go ahead for properties of light, right? Let's say. Okay. So first of all, geometric properties of light. What is properties of light? So number one property is the speed of light assigned by small c. C, the value of C is, you all know well, nearly 3 into 10 to the power 8 meter per second. Okay, approximately 3.7 meter, so approximately, right? Approx. Number two, that is important. This is the wavelet. This is the velocity of light. The maximum possible speed in entire universe. That is the speed of light. And here, that is light is a, as I told this, light. Light is electromagnetic. Electro. Light is a electromagnetic. Electromagnetic wave. Wave. And this is given by, as I told, this is Maxwell. Maxwell, right? Maxwell's quantum theory जो हम लोग आगे पढ़ेंगे. It consists of, as from the name that is clear, electro, and this is magnetic. Here this is one is electro and that is magnetic. So this one is, just wait, let me open the board, new board. Here some problem arises, as you know. close this. Okay, let's see. Number 3. Light has electromagnetic waves. Let's see about this one. This is electromagnetic waves. Is that we can recall. I'm facing some problem in the board, so I'm closing this board and open new board here later on. Don't worry. Sure. No problem. Okay. Just wait. Just wait here. It's okay. Are you all getting?
Yes, sir.
Okay. इसलिए बोर्ड में कुछ प्रॉब्लम चल रही थी, फिर न्यू बोर्ड तो वो फ्लश हो गया होगा. मैं टॉपिक फिर से एक बार लिख रहा हूँ पड़ेगा. डोंट वरी. लेट मी राइट ज्योमेट्रिकल ऑप्टिक्स. वो सब नहीं लिखेंगे, प्रॉपर्टीज वाली फिर से लिखेंगे. ज्योमेट्रिकल ऑप्टिक्स. So what we were discussing here, that was the properties of light, right? Properties of light. Light. In properties of light, what we have to discuss, that is number 1, speed of light. You all know well that this is the speed of light in vacuum. The speed of light, speed of light in, that what I wrote, that c is equal to 3 into 10 power 8 meter per second. So that is in vacuum. In vacuum, you can say, right? In vacuum, that is 3 into 10 to the power 8 meter per second, approximately, right? Number 2, the property is, that is light is electromagnetic nature. Light is electromagnetic waves. is electromagnetic wave, and this wave is produced by uh, Maxwell, right? This concept is produced by Maxwell. Maxwell was scientist, Clark Maxwell. In this here, that is the electric vector and magnetic vector. So if you see here, this is let's say this is here electric vector, okay, and what do you call as fine, and this what we say magnetic vector. This is here magnetic vector, right? This is what we call here. Let's say this is electric vector. Actually, these two vectors are mutually perpendicular to each other. You know, this one is, let's say, electric vector, and this one is magnetic vector. Magnetic vector is assigned by capital B, so we use the letter B over here. And one more, that is the light travels in a resultant vector of this electric and magnetic vector, which is called electromagnetic waves. So light travels in this way, in this direction. That we say here, you can see light travels in this way. That is called propagation of light, you can say. This is propagation of light. Propagation of light. Okay. This one. This is the concept here. Actually, here also the wave moves in electric vector, and here B moves all in this along with this axis. Suppose let's say this is you can say this one is x-axis or y-axis, any. Let's say this is y-axis, this is z-axis. Then on along x-axis, the propagation is there of light. Or you say, let's say this is x-axis, y-axis. Then you find on z-axis that is moving with propagation of light. Light moves here in this axis. So they all vectors are mutually perpendicular, right? But this is the modern definition of light. So light carries, what light carries? Light, you know that it carries energy and momentum both, right? Because it has some lighter particles also that called photons. So that we say light carries. Light carries.
Hello, sir.
Yes.
Can you scroll up a little bit?
Pardon?
Can you scroll up a little bit?
Yeah, exactly. Is this okay?
Yes.
Light carries energy and momentum. Energy and momentum. Light carries energy and momentum. Acha. And light goes like this way. The velocity of light, that is, that is the wave velocity. What is the wave velocity? From 6th class, we are learning that V is equal to frequency into lambda. That is the wavelength of the light. Let lambda be the wavelength of the light. So let's say fourth property will be uh, V is equal to frequency into lambda, right? For different frequency, you will find different colors of light. That's okay. That also depends on lambda. So because f and lambda both will be vary, because velocity of light will be same. Na? Velocity of light is here 3 into 10 to the power 8 meter per second, which is the fastest thing which can move in the entire universe. 3 into 10 to the power 8 meter per second. V is equal to F means 3 into 10 power means are you getting means how much? In 10 to the power 6 you find 10 lakh nearly. So 2 means 3000 how much? 10 to the power 8 zeros are there within a second, this much length, meter length. So V is equal to F lambda. By the help of this, for different values of lambda, you can say you will get different types of lights are there. So let me show this here. How which type of lights and what are the usage of these all. I will show later. One thing is there that when here later on we will go for different properties as reflection, refraction, and others also. But when light gets reflected in same medium, it suffers no change in frequency, speed, and wavelength. Right? Frequency, speed, wavelength इस सब में कोई भी change नहीं होगा क्योंकि same medium है. जब medium different होंगे then only it suffers changes. Right? Frequency of light remains unchanged when it gets reflected or refracted. दोनों में reflection और refraction दोनों की phenomena में frequency change नहीं होगी. ठीक है, frequency of light same रहेगी. Light की characteristic depend करता है, means nutshell में conclusion ये है कि light की जो characteristic होती है वो frequency पर ही depend करता है. ठीक है, तो अलग ही property. This one is also very important. You can note down here. But before this, let me explain this one. What is that? Let's see. यहाँ note कर लिया इतना. Let's see about this one. I have a data over here. You can see that is the wavelength. What we recall here. Let's see about this one. Wavelength decreases, frequency increases, and energy also increases. So what depends on? This is the pattern of the light. You can see over here. अब इसको लिखने में इतनी टाइम लगेगी तो इसलिए मैं यहाँ पे इसकी स्नैप पड़ा हुआ है तो मैं यूज़ कर सकता हूँ इसका. देखिए भाई. So what the pattern of lights are there? You can see over here. The frequency is 10 to the power 4 to 10 power 20, and the visible range is over here. जो ये आपकी colors of light दिख रही है. This is the visible range. You can see here. 0.5 into 10 to the power 6, right? This is a visible range. So, radiation type of wavelength. This is the radio waves. Okay, and here microwaves, infrared, visible range, ultraviolet, X-rays, and gamma rays, right? And this is the frequency here. Approximate scale of wavelength is this much. So in this frequency, within this frequency, this is the light only visible. Clear to everybody? This is the order of light, you can say. Let me see. So according to different frequency, you will find different colors of light, you can say. And analogous concept is also in every wave. This type of concept is there. Just like in sound wave, different for different frequency, you will find different pitch, right? One more thing I want to show you here. There is a usage of this all. It's okay. So what is the usage? Let's see over here. Analogous to this, same here, you can find this as a usage also. This will be the usage. This is a general knowledge type of question, you can say. Okay. Let me say here. So look at the point here. This is the visible region in which we find different color of light. and when frequency is we find here higher from this part, then we go in this scale. Then there is the infrared region, microwaves, right, and here radio waves, and here X-rays. Although for radio waves and these all antennas are required, and here some other manipulations we can find this as X-rays. Here there is no requirement of any media. So ultraviolet, X-rays, and this is gamma rays. This is nearly 10 to the power 20. The order is this much. It's okay. Are you ready? So one thing I want to show over here that means you can write here, when light gets reflected in same medium, when when, when light uh, gets reflected in same medium, okay, reflected in same medium, same medium, it suffers no change. It suffers no change, no change in किन चीज़ों में चेंज नहीं होगा. Frequency, that is standby nu, right, and here that is the speed of light, and here also wavelength. तो इसमें कोई भी changes नहीं होगा, ठीक है. अच्छा, और अगर लाइट एक मीडियम से दूसरे मीडियम में जा रही है तो यू नो दैट इज फ्रीक्वेंसी डजंट चेंजेस. तो नेक्स्ट प्रॉपर्टी 6, दैट इज frequency of light, frequency of light, frequency of light remains unchanged, remains unchanged, unchanged when it gets reflected or reflected, when it gets when it रिफ्लेक्शन में तो कुछ भी चेंज नहीं होगा, रिफ्रैक्शन में भी नहीं चेंज होगा. when it gets, तो यहाँ पे ये भी लिख लेंगे, रिफ्लेक्टेड वाला भी लिख लेंगे, हालांकि लिख चुके हैं पहले. रिफ्लेक्टेड और रिफ्रैक्टेड, ये दोनों. रिफ्रैक्टेड, तो रिफ्रैक्शन में भी चेंजेस नहीं आएंगे, राइट. चलिए बना लेते हैं. यहाँ से सपोज ये मीडिया जो है चेंज हो रही है, मीडियम, राइट. लेट्स से दिस इज मीडियम 1 एंड दिस इज मीडियम 2, मीडियम 1 and here that is medium 2, medium 2, let me write this medium 2, okay. So you can see here. One thing I want to notify over here, that is, so let's see, light is coming here. This is, let's say, normal, okay. This is non-normal, and here light is incident with this way, light is incident. This one is light is incident, right, and then after means when it strikes to some medium which divides, just like this is air, this is water, or some other medium like this, means two different mediums are there. So the two different phenomena occurs. Some part of the light it goes like this way, some part of the light goes like this way. You can see that. Okay, so let's say this one. It may be reflected also, right, and some part of the light may be refracted also, like this. So it will be the bending phenomena, may go away from the normal, may go towards the normal, like this way. Actually, previously the position of the light was this here. You can see the position of the light is this one. You can see this one is the light, but here, due to the medium, due to the presence of this medium, this one is the medium. So due to the presence of this medium, here light, some part of energy comes in refraction and some part of energy goes in reflection. In both the situation here, frequency doesn't changes. Only the thing is frequency of the light remains unchanged. That is remains unchanged, right? So here you can see that let me write, this is incident ray. This is incident ray. Incident ray. And this is, you say, reflected. Reflected. And this we can say refracted. Refracted. Okay. This is refracted. And this what we call reflected, and this is the incident ray. This is the incident ray. Okay, that's what we call incident ray. And this we say reflected ray. This is reflected ray. Okay, and this is reflected ray. This is reflected ray. Okay. So in this, what happened that for incident ray, you see, for incident ray, what is that? Let's say the velocity, frequency, and here that is intensity, whatever that is, the terms. Let me put on over here for this incident ray. Let's say this is V is the velocity, right? F is the frequency, and lambda is the wavelength, and I is the intensity for this light, the light which is incident over here. So what happens when the light will be refracted? So the light when the light will be refracted, then let's say this is what happened. This is V dash, means it is bending towards the normal. Means like this is light is coming from air to water. Air to water. Water is a dense media. When it is comes in dense media, then V dash means velocity. V is velocity, and here V dash velocity changes. But when we write D dash means something different. V dash, and here F frequency. Frequency doesn't change. Here also F. Here also F. Right. And then I have to write for lambda. Lambda changes. Yes, lambda also changes. Lambda dash changes. Okay. So what about this one? Let's say this is I. What we say here? I. So here you can say I. Let's say double dash, because for this one we write I dash. So I double dash, which is also less or equal to I, and these all are lesser, means dash one. What about this one here? What happened? So in reflected, let's say this is velocity is. What about velocity? As it is traveling in same medium, so velocity will be same or different. Here velocity is different. What about this here velocity? Velocity will be same or different after reflection.
Same.
Yes, because medium is same. Due to the medium, as medium is same, so velocity will be same, right? So I used to write here V for this one, right? So let's say this is V, and so let me put down here. Here, this one is V. Okay, velocity will be V. Velocity is V. Okay, and what about frequency? Frequency will be same or different? Frequency will be undoubtedly, frequency doesn't changes in either reflection or refraction. Right? What about lambda? Lambda will be changed or not? Lambda will be changed or not? Eh?
No, sir.
Because velocity and frequency both are not changing. So lambda will be also there. The formula was V equal to F into lambda. You can see over here. The formula was V is equal to F into lambda. You can see. Where's the formula? Yes, V is equal to F into lambda. Are you getting? Because F and lambda, both of them, velocity is not changing, F is not changing, so lambda will also not change. So, 11 point here. So what about Vf lambda will be same. But what will be changed? Is this something change? E, I intensity. Intensity is here I double dash and here I dash will be there. So intensity will be changed. Intensity is directly depends on, you can say, that is energy, right? So less or equal to I. This one is I. Is this clear to everybody? What changes and what doesn't changes in the reflection and refraction? Although we have to go for another more phenomena of light, that is called some other phenomena, that is interference, diffraction, and else also. Yes, something are you want to say?
Sir, what is meant by intensity?
Pardon?
What is meant by
Acha,
intensity?
intensity is that means suppose a light is coming. Intensity is directly proportional to energy. Later on we will discuss in detail. Means suppose some of the light is coming over here. By this only light, some part of the light is reflected and some part of the light is refracted. Suppose according to expert depends on which type of the medium, this one dividing plane, this phase. This one is the medium 2 and this one is the medium 1. Medium 1 and medium 2, what the plane is there? Suppose we are putting a simple mirror. So in simple mirror, entire light doesn't reflect. Means whatever the light is coming over here on the mirror, you can't say that it's 100% light is reflecting. It's not an ideal mirror, right? Some part of the means you can say some glass plate which is a transparent. So entire glass through glass plate, entire light doesn't refract. Some part of the energy was missing. Means suppose 80% of the light, this one you can say refract. So where the 20% goes, so 20% goes in refraction, and that 20% 80% concept, that is called reflection and refraction. Means if the maximum part of the light reflects, then we say the reflection occurs. If the maximum part of the light refracts, then we say the refraction occurs. It's okay. So that is the percentage of the means means the what the energy we are using over here for reflection and refraction. That is the analog, which is proportional to intensity, and that is the intensity. We say intensity here is less than I, and here also less than I. Are you getting?
Yes, sir. Sir, but energy is equal to hc by lambda, and in this case, v is also constant and lambda is also constant, so energy should remain constant.
No, that is not the energy. Means that is called means we have to go for intensity, which is acha. Actually, this is not the part of syllabus. We have to go for this one in wave optics. We have to go, and then we have to decide. Intensity is now proportion to square of the amplitude. That's what I mean over here. Intensity is proportion to square of the amplitude, you can say. That is uh, actually what happens here. If you see in wave optics, we will discuss in detail later on. You can see over here that as you say that light travels in a straight line. So light doesn't travel in a straight line. If you see over here that some slit is there. Here, this one is the part of the slit. And if light is coming like this way, straight, right? Light coming like this way, straight part. So what we see over here, if you see the entire, this one is the screen, then what you will find here, the light from this orifice, what is the slit over here? You can say slit. Let this be length is A over here for this slit. Let the length of the slit is width of the slit. You can say width of the slit is A. So light won't comes like this way. Light won't comes like this way. No, this is not a way. If the light travels in a straight line, then we will find this. It's okay. Then what we find here, the light goes like this way. Light goes like this way. It's okay. Why so? This phenomena is called diffraction. These are all due to the wave nature of light. It's okay. So it depends on which type of medium. If the medium is isotropic, it's okay. If we say the medium is isotropic, then you say behavior is same in all direction, right? And the obstacle passed in which the light moves as the opening through which the light move is not very small. Okay, so that is the concept here. Later on, we'll go for this one in interference chapter. Means you say intensity is directly proportional to the square of the amplitude, and the amplitude that is the depends on width of slit. Clear?
Okay, sir.
I will define intensity later on. Don't worry. And that is intensity is also a vector quantity of this one light, right? So let's go ahead and we will start today's topic, that is called reflection. So we will go for, in this chapter, we will go for reflection and refraction in detail by plane and curved surface. So today's the topic is reflection of light. So let's start. Reflection of light, which you have studied in class 8th level. So today's entire lecture is based on class 8th level, nothing else. 8th class student can also understand this topic. Reflection of light. Okay. Reflection of light. So, what is the phenomena of reflection? What is reflection? When light ray strikes, when the light ray strikes the boundary of two medium, means if you see the boundary of the two medium, let's say this is the boundary here. We use this as boundary. Let's say this is the boundary of the light, right? And here, when the light ray strikes, let's say this is the boundary of the medium. Here medium 1 and here that is medium 2. Chalo, take away. So what happened here? This one is medium 1 and this one is medium 2, and this one is the you can say boundary of two medium, right? So boundary means before this one medium and after this another medium. So when the light comes like this way, you see, let's say light strikes like this, right here on this medium, okay, light comes like this way and light comes like this way. So it's depend on which type of boundary is there, right? So after striking these all boundary, the light goes away. You can say, or you can say light is turned back into the same medium. The phenomena is called reflection. If the light turns in the same medium, if the light turn back in the same medium, right? Same medium, light turn back in the same medium like this way and like this way, then the phenomena is called reflection. Is this all right? This phenomena is called reflection. So what is the definition of the reflection? Means when light ray strikes in the boundary of two medium, you can say any, such as like air, glass medium, or kerosene, benzene, any type of medium you can say, that is that. Means so a part of light means a part of light, because not is the ideal reflection. No? Some part of the light goes in refraction also, right? And even some part of the light, not only for reflection and refraction, some part of the light will be absorbed by this medium also. this one dividing plane, that boundary will also absorb according to the characteristic of the material. So whatever the light is coming over here, that is not 100% energy, is 100% intensity is just moving towards in the same medium. Some part of the light goes in refraction, some part absorption, and some part this one reflection. But most of the part goes in reflection. The phenomena is called reflection. When most of the part goes for refraction, the phenomena is called refraction. When most of the part goes for absorption, the phenomena is called absorption. So three phenomena we will find when the light ray strikes on this boundary. One is reflection, refraction, and absorption. Right. So we will today discuss detail about reflection. Now it's depend on the medium. Which type of medium is coming over here? And just they are facing incident ray. This one is incident ray. These are the incident ray, and these are the reflected ray. So here we say when light ray strikes the boundary of two medium, that is means such as air, glass, or whatever there is. So a part of light, have to say a part of light is turned back into the same medium. This is called reflection of light. You can write also. May I write or it's okay? So here reflections are two types. One is called regular reflection, regular reflection, which is here. The diagram is given over here. This diagram is for reflection. Okay. This diagram is for regular reflection. Regular reflection. Reflection. Right. And another that we will go for diffused reflection. Second type of reflection is called diffused reflection. Diffused reflection. Reflection. Okay. So this one is you say regular reflection. Okay. Regular reflection, you can say. This one is first, and second, that is called diffused reflection.
सर कोई मीटिंग में आना चाहता है.
क्या हुआ?
मीटिंग में आना चाहता है. कुमुद.
कुछ बोल रहे हैं क्या?
सर एक लड़का मीटिंग के अंदर आना चाहता है.
अच्छा, वो मेरा राइट नहीं, उधर ऑफिस में बोले ना, वो एंट्री लेंगे. उन्हें कैसे बोला? उनके उससे बोल दे कि ऑफिस में बोले डायरेक्ट मैम को. चलिए सो यहाँ पे देखेंगे. अच्छा, ये सेकंड वाला ना, डिफ्यूज्ड रिफ्लेक्शन. ये पहला वाला तो रिफ्लेक्शन आप लोग समझ रहे होंगे, लेकिन ये सेकंड वाला जो रिफ्लेक्शन है वो समझने नहीं समझे होंगे, वो नहीं जानते होंगे शायद. जान रहे हैं डिफ्यूज्ड रिफ्लेक्शन क्या होता है? वो जान रहा है? What is diffused reflection? First one is that regular reflection, जो कि ये है, और diffused reflection. अच्छा, what is regular reflection? Reflection तो आप लोगों ने समझ लिया. Reflection का definition लिखते हैं कि it's okay. इसका definition लिखते हैं कि clear है. बोलो भाई, लिख देता हूँ मैं. When light ये सब लिखने की तो जरूरत नहीं है वैसे. When light rays strikes. इसको छोड़ दें कि लिखें? When light rays. तो बोर भी चलेगा. Strike. ठीक है. Strike and turn back. कहाँ पे strike करेगा? Strike the boundary of two medium. ठीक है. Then a part of light strike. ये जरूर लिखेंगे. A part of light. Part of light. Part of light is turned back. Is turned back. Back. Right. Into the same medium. Into the same medium. Same medium. Right. This is called reflection of light. क्या प्रॉब्लम आ रही है? Same medium. ठीक है. Medium होगा. Medium. This is called reflection of light. It's called a reflection of light. A reflection of light. Right. And what is a reflection? A regular reflection? When this one reflection takes place, this one from perfect plane surface. This surface is called perfect plane surface. Then it is called a regular reflection. Rather than this perfect plane, if we say diffused for this one, means which type of plane will be there? You can say here, you can consider like this way. Let me draw over here, right? So when you see over here, then light coming like this way, light is coming like this way. Let's say this light, let's say this light is coming like this. When it strikes to here, then it goes after reflection, right? After reflection, what is that? Right, like this one, and when it goes like this, also. When it goes like this way, then you can assume that the normal will be here. Then the after reflection, the light goes like this. Okay, light goes like this way. And suppose somehow if the light strikes over here, although all the lights are coming in the plane format here, this light comes like this way, and after reflection, the light can go like this way also, right? So after reflection, the light is going like this way, and here also after reflection, light is going like this way also, right? Light is going like this way. So after a reflection, the light going like this way, like this way, like this way, in random order, means directions. All the incident lights are going after reflection. They are also parallel, as parallel rays are coming towards the medium, and the parallel rays are also after reflection they are going. But here, after reflection, if the rays are not parallel, then such reflection is called diffuse reflection. What is the reason behind? Due to this surface. Take it. Why? The surface is rough. Here the surface is rough. Surface is right, and here the surface is smooth. Surface is smooth. It's okay. So such reflection is called regular reflection. अच्छा, ये कैसे रिफ्लेक्शन होते हैं एग्जाम्पल्स में देते हैं. हाँ बोलो क्या.
Can you scroll up a little bit थोड़ा ऊपर का लिखना.
हाँ यार कोड का थोड़ा इशू आ रहा है. रिफ्लेक्शन ऑफ लाइट. ठीक है. अच्छा, ये सारी जो रिफ्लेक्शन है वो कैसे है. डिफ्यूज रिफ्लेक्शन का आपके एग्जांपल्स क्या है कोई बताया क्या. डिफ्यूज रिफ्लेक्शन के मतलब इरेगुलरिटी रहनी चाहिए सरफेस में उस पर. तो जैसे कहाँ पे रहेगा फ्रिक्शनल सरफेस कैसे रहेंगे. जो आपके सिंपल फेंस है, जो घरों के वॉल है, न्यूज़पेपर्स है, तो न्यूज़पेपर से जो लाइट रिफ्लेक्ट हो रही है, ठीक है, तो ये सारे जो है क्या होंगे डिफ्यूज रिफ्लेक्शन होंगे. रिफ्लेक्शन पढ़ रहे. और सिंपल मिरर जैसे है तो उससे रेगुलर रिफ्रैक्शन हो रहा है. ठीक है, बस यही है. तो होप सो आप समझ पा रहे होंगे डिफ्यूज रिफ्लेक्शन क्या है. नाउ गो अहेड फॉर लॉ ऑफ रिफ्लेक्शन. अब हम लोग पढ़ेंगे लॉ ऑफ रिफ्लेक्शन. आगे बढ़े.
Wait.
सर एक मिनट पीछे ना और वो पेज पर. अच्छा.
ये ये सब करें जल्दी जल्दी. ये सब इंट्रोडक्टरी है, ये तो न्यूमेरिकल्स करना है. ये क्लास 6-7 की बात चल रही. हालांकि जिस जिस पॉइंट पर जो हम लोग अप्लाई करेंगे ना, जहाँ पे लाइट इंसिडेंट हो रही है, यहाँ पे अगर आप देखें लाइट जहाँ जहाँ जिस किसी पॉइंट पे इंसिडेंट हो रही है, वो सरफेस के मटेरियल पे नहीं डिपेंड कर रहा है. वो तो इसी तरह का रिफ्लेक्शन कर रहा है. वो यहाँ पे भी अगर आप ड्रॉ करें, यहाँ देखें नॉर्मल ड्रॉ करें, तो जो लॉ ऑफ रिफ्लेक्शन होता है वो यहाँ भी वैलिड होगा, लेकिन सरफेस के पैटर्न पर डिपेंड करता है. ये जो मैं दिखला रहा हूँ पैटर्न, ये माइक्रोस्कोपिक मतलब जो व्यू है, ये यहाँ से यहाँ तक मतलब पेपर के जो न्यूज़पेपर का एक दो छोटे मॉलिक्यूल्स है वो है. ये नहीं कि 1 सेंटीमीटर या 1 मिलीमीटर का ये डिस्टेंस है. ये बहुत ही टीनी डिस्टेंस है. इसको माइक्रोस्कोपिक व्यू लिया गया है तब ये दिख रहा है. समझ में. इस जगह पे जब ये स्ट्राइक कर रहा है तो ये लॉ ऑफ रिफ्लेक्शन को फॉलो कर रहा है. इस वाले को यहाँ के भी फॉलो कर रहा है. तो न्यूज़पेपर वगैरह के जो पर जो लाइट गिर रही है और वहाँ से रिफ्लेक्ट हो रही है, तो वो वहाँ पे क्या है, फ्रिक्शनल सरफेस है, सरफेस रफ है. तो वो फ्रिक्शन क्यों बन रहा है, फ्रिक्शन का जनरेट क्यों हो रहा है. सरफेस तो आपको ऐसे ही दिखेगा, एक स्ट्रेट लाइन जैसा ही दिखेगा, लेकिन जब माइक्रोस्कोपिक व्यू आप इसका लेंगे तो यू विल गेट लाइक दिस वे, राइट. और इसको और भी व्यू इसका जूम करके आप देखेंगे तो उसका व्यू ऐसा टाइप का हम लोग को दिखेगा. तो वो ये वाली सिचुएशन है. समझ में. चलिए तो आगे बढ़ते हैं हम लोग. अभी पहला पढ़ेंगे न्यूटन्स लॉ ऑफ रिफ्लेक्शन. तो सबसे पहले, चूंकि यहाँ पे न्यूटन इसलिए बोल रहा है क्योंकि न्यूटन ने ही सबसे पहले लाइट के बारे में बताया. वो उसी तरह से बताया जैसे कि बॉल को अगर हम लोग वॉल पे मारे, तो अगर 45 डिग्री एंगल पर दीवार पे इस वॉल पर मतलब थ्रो करें, तो 45 डिग्री एंगल पर ही वो रिफ्लेक्ट होकर के रिबाउंड करेगी बॉल, जैसे कोलिजन में पढ़ते थे. ठीक है. तो उसी कंसेप्ट के अकॉर्डिंग टू न्यूटन, लाइट हैज अ कॉर्पस्कुलर नेचर. कॉर्पस्कुलर नेचर मतलब पार्टिकल से मिल करके बने हुए हैं. कॉर्पसल्स उसको बोलते हैं. कॉर्पसल्स दैट इज कॉल्ड पार्टिकल्स. तो छोटे छोटे पार्टिकल से मिल करके बने हुए लाइट अकॉर्डिंग टू न्यूटन, राइट. लेकिन अभी तो बता दिया लाइट क्या है. लाइट जो है पार्टिकल नहीं है, वेव नहीं है. ये पार्टिकल नेचर और वेव नेचर में डिस्कशन चलता है. तो अकॉर्डिंग टू मैक्सवेल्स, ये एक जो पैकेट्स के फॉर्म में चल रहे हैं लाइट, दैट इज एनर्जी पैकेट्स के फॉर्म में चल रहे हैं. तो चले हम लोग देखेंगे क्लासिकल मैकेनिक्स की तरफ से जो है यही लाइट की पढ़ाई करेंगे, जो न्यूटन साहब की जो पढ़ाई चल रही थी वो. तो पहला हेडिंग डालेंगे हम लोग लॉ ऑफ रिफ्लेक्शन. सो गिविंग लॉ ऑफ रिफ्लेक्शन क्लास 6 से पढ़ते आ रहे हैं लॉ ऑफ रिफ्लेक्शन. तो अब हम लोग क्लास 12th में कैसे पढ़ेंगे? क्लास 12 में लॉ ऑफ रिफ्लेक्शन बदल थोड़ी जाएगा, तो वही रहेगा ना, रिफ्लेक्शन बदल जाएगा। क्लास 12 में लॉ ऑफ रिफ्लेक्शन बदलेगा थोड़ी भाई, लॉ ऑफ रिफ्लेक्शन तो वही रहेगा, ठीक है, लॉ ऑफ रिफ्लेक्शन। तो देखिए भाई, लॉ ऑफ रिफ्लेक्शन वही रहेगा, ठीक है ना। तो फर्स्ट इसमें टू जो लॉज रहते हैं न्यूटन साहब के, वही हैं। फर्स्ट लॉ क्या है? द इंसिडेंट रे, रिफ्लेक्टेड रे एंड द नॉर्मल एट द पॉइंट ऑफ इंसिडेंट लाई ऑन द सेम प्लेन। यही बोलते हैं ना, यही यही चीज क्लास 6 से पढ़ते आ रहे हैं, तो ऐसे ही पढ़ा है। तो क्या लिखेंगे? पहला पहला क्या है? द इंसिडेंट रे, लेट मी राइट द इंसिडेंट रे, ये वर्ड टू वर्ड ऐसे ही रहना चाहिए, लॉज है इंसिडेंट, इसमें कोई भी वर्ड चेंज नहीं होना चाहिए। द इंसिडेंट रे, राइट, लॉज में चेंजेस नहीं होने चाहिए भाई, ठीक है, लॉज, अच्छा लॉ नहीं होगा, लॉज लिखेंगे, क्योंकि दो लॉ है ना, ये दो लॉज अपने पास है, ठीक है। तो चलिए, लॉज चलिए, द इंसिडेंट रे क्या लिखेंगे? द इंसिडेंट रे, और क्या है? द रिफ्लेक्टेड रे, रिफ्लेक्टेड रे, रिफ्लेक्टेड रे and the normal, and the normal, and the normal, okay, at the point of incidence, at the point of incidence, you know, incidence, point of incidence lie in the same plane, at the points of incidence lie in the same plane, in the same plane, okay, and the plane of incidence, this plane is called plane of incidence भी बोल सकते हैं, plane of reflection भी बोल सकते हैं, ठीक है। और this plane is called, this plane is called plane of incidence, called plane of incidence, plane of incidence, incidence, and ब्रैकेट में, और plane of reflection, और plane of reflection भी बोल सकते हैं, plane of reflection, क्योंकि रिफ्लेक्शन भी वहीं पे हो रहा है और इंसिडेंस भी वहीं पे हो रहा है, तो इसलिए दोनों नाम बोल सकते हैं उस प्लेन को, प्लेन ऑफ रिफ्लेक्शन। ये सब भी जानना चाहिए, तो क्वेश्चन में ये सारी चीज़ें भी दे देते हैं। एंड अच्छा, इस ये जो चीज़ लिखा हुआ है, ये क्लास 6 से ऐसे लिखते आ रहे हैं, अब क्लास 12 में पढ़ेंगे तो ये चीज़ तो ऐसा लिखेंगे नहीं। तो आप लोग चूंकि इंजीनियरिंग बैच के ना सब लोग, तो मैथमेटिकली इसको कैसे लिख सकते हैं? इस ये जो स्टेटमेंट लिखा हुआ है, इसको मैथमेटिक्स में कैसे लिखेंगे? मैथमेटिकली हाउ विल राइट, तो बताएगा? बोले भाई, अगर हम लोग यस
वेक्टर्स के फॉर्म में,
वेक्टर्स का,
हाँ वेक्टर के फॉर्म में लिखना है, करेक्ट। तो कैसे लिखा जाएगा? ये देखो, ये आपका कोई प्लेन है, और यहाँ पर फिर हम लोग को ये इस तरह से लिखना होगा, इंसिडेंट रे ले लेते हैं एक, ये दिस वन इज इंसिडेंट रे, ये दिस वन इज इंसिडेंट रे हो गया, फिर यहाँ से रिफ्लेक्टेड रे रहेगा, रिफ्लेक्टेड रे, दिस वन इज रिफ्लेक्टेड रे, एंड दिस व्हाट वी कॉल नॉर्मल, ये जो है नॉर्मल रे, दिस इज हियर दैट वी से नॉर्मल, ये नॉर्मल ले लेंगे। ओके, ये अपना नॉर्मल, ओके, ये नॉर्मल है। अब ये इंसिडेंट रे और ये तो इसको अभी आगे लिखेंगे, ये जो एंगल्स इक्वल होते हैं, ठीक है, तो एंगल इस तरह से रखेंगे कि ये दोनों एंगल इक्वल होंगे। तो पहले ये वाली बात को लिखे ना मैथमेटिकली, ये वाली तो आपकी आ गई इंसिडेंट रे, ये आ गई आपकी इंसिडेंट रे, राइट, और ये हो गई आपकी रिफ्लेक्टेड रे, ये इधर जा रही है, ठीक, और ये नॉर्मल हो गया, यहाँ पे एंगल आई और एंगल आर ये दोनों इक्वल होता है, इंसिडेंट रे और एंगल ऑफ इंसिडेंस, एंगल ऑफ रिफ्लेक्शन, ये सेकंड वाला लॉ होगा। तो इसको अभी बाद में लिखेंगे हम लोग, लेकिन पहले फर्स्ट लॉ को मैथमेटिकली लिखा जाए। तो द इंसिडेंट रे, रिफ्लेक्टेड रे एंड द नॉर्मल at the point of incidence lie in the same plane. This plane is called plane of incidence or plane of reflection. तो क्या बोलेंगे इसको, ये r वेक्टर है, ठीक है, ये i वेक्टर है और ये नॉर्मल वेक्टर है, तो तीनों ही वेक्टर जो है सेम प्लेन में लाई कर रहे हैं। तो तीन वेक्टर को प्लेनर होते हैं, वेक्टर चैप्टर पढ़ लिया आप लोग कि नहीं? अरे इसमें भी तो बताया आपको, फिजिक्स में भी तो बताया गया। चलिए इसको लिखिए, कैसे लिखेंगे? बोलिए, इसको कैसे लिखा जाएगा? बोलिए, वेक्टर आर, वेक्टर आर ये क्या है? रिफ्लेक्टेड रे, ठीक है, तो वेक्टर आर डॉट स्केलर ट्रिपल प्रोडक्ट हुआ और आई क्रॉस एन, इंसिडेंट रे और एन वेक्टर का क्रॉस प्रोडक्ट, और इन लोगों का डॉट प्रोडक्ट, ये आर वाले का डॉट प्रोडक्ट, तो ए डॉट बी क्रॉस सी। अच्छा, इसको ऐसे भी कर सकते हैं, जैसा बताया था सिमेट्रिकली डिटरमिनेंट में होता है ना, ए बी सी होता है, तो इसको आगे भी बढ़ सकता है। तो ये क्या लिखेंगे, आर आई एन है, तो एन डॉट क्या लिख सकते हैं, आई क्रॉस आर, आई क्रॉस आर कर दो, यानी इंसिडेंट और रिफ्लेक्टेड का क्रॉस प्रोडक्ट, और इससे एन का डॉट प्रोडक्ट कर दो, या फिर क्या करोगे, ये भी कर सकते हो भाई, या फिर आप ये भी कर सकते हैं, ओके, यहाँ पे देखो, ये इज इक्वल टू क्या लिख सकते हैं हम लोग, एन डॉट लिखे ना, और क्या लिख सकते हैं, आई एन आर, मतलब आई एन आर नहीं लिखे ना, आई लिखो, आई डॉट एन क्रॉस आर, आई डॉट एन क्रॉस आर, ये सभी क्या होंगे, थ्री वेक्टर्स कोप्लेनर है, तो इनसे बनने वाला वॉल्यूम ऑफ पैरेललोपाइड, ये क्या हुआ, ये वॉल्यूम बनेगा। वॉल्यूम का फॉर्मूला क्या होता है, ए डॉट बी क्रॉस सी, तो ये देखो, ये आई वेक्टर है, ये वाला क्या है, आई वेक्टर है, और ये वाला क्या है, आर वेक्टर है, और ये वाला एन वेक्टर है, देखा भाई, ये वाला अपना एन वेक्टर है। तो ये तीनों ही क्या हो रहे हैं, सेम प्लेन में लाई कर रहे हैं, मतलब किन्हीं दो से डॉट प्रोडक्ट क्रॉस प्रोडक्ट करोगे, तो क्रॉस प्रोडक्ट करोगे तो ये हवे में आ जाएगा, और इससे फिर एन डॉट प्रोडक्ट करेगा तो फिर इस प्लेन में वापस गिर जाएगा। और अगर कब ये गिरेगा, ये तो इनसे बनने वाला वॉल्यूम बना, लेकिन इस वॉल्यूम को जीरो कर दिया जाए, इसको जीरो कर दिया जाए, यानी ये जीरो कर दो या ये जीरो कर दो या ये जीरो कर दो, एक ही बात समझना है। वेयर आई एंड आर आर द वेक्टर्स ऑफ, ये सब आप लिख लोगे।
फिर एक बार वापस बताओ ना।
अच्छा, पहले ये देखो, ये चीज़ छोड़ दो, ये चीज़ हमेशा ज़रूरत पड़ती रहेगी फिजिक्स में, इस क्वेश्चन सब यहीं से होंगे हम लोगों के, लेकिन पहले ये ए डॉट बी क्रॉस सी समझो, आपको प्रॉब्लम कहाँ आ रही है, ए डॉट बी क्रॉस सी समझने में। That is also known as a scalar triple product. That is also called a scalar triple product. अब इस पर क्वेश्चन लेते
सर
हैं।
पूरा क्लास का वेक्टर्स नहीं पढ़ा है, जो 11th में बेसिक पढ़ा थे वही पढ़ा है।
तो एकदम 11th में बेसिक में मैं पढ़ाया हूँ ना, मैं एक्स्ट्रा क्लास लिया था वेक्टर का ना, नहीं समझे?
सर वो वॉल्यूम पैरेललोपाइड वो नहीं समझा।
करेक्ट, वही 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 चीज है, वॉल्यूम ऑफ पैरेललोपाइड। ये समझाया ना वॉल्यूम ऑफ पैरेललोपाइड क्लास में? नहीं समझे तो मैं एक्सप्लेन करूँ?
नहीं सर।
अच्छा मैं
नहीं सर,
एक्सप्लेन,
नहीं समझा।
अच्छा मैं एक्सप्लेन कर रहा हूँ रफ में, ध्यान रखो, ध्यान रखो। ये ले लो एक्स एक्सेस, ये ले लो अपना, ये इसको एक्स एक्सेस ले लो, इसको लिख लो, ये एक्स एक्सेस हो गया आपका, ये हो गया आपका वाई एक्सेस, और ये हो गया एक्स एक्सेस, और यहाँ पे एक और वो खड़ा कर दो जेड एक्सेस। एक्स एक्स से क्रॉस करोगे वाई को तो क्या मिलेगा? जेड एक्सेस, राइट? ये हो गया अपना जेड एक्सेस। इतनी बात समझ में आई? अब देखो इसमें दो वेक्टर्स को हम लोग खड़ा करेंगे, तो कैसे वेक्टर्स रखेंगे? ये वेक्टर ए, एक वेक्टर को हम लोग ले रहे हैं यहाँ पे वेक्टर ए, तो ये देखो ये एक वेक्टर हुआ अपना ए, ठीक है? या इसमें आ जाओ, इस वेक्टर को लेकर के ये वेक्टर ए हुआ, और यहाँ पर एक और वेक्टर मैं ले रहा हूँ, दूसरे कलर का वेक्टर ले रहा हूँ, तो कलरफुल बना रहा हूँ। ये वेक्टर हो गया अपना ये बी। ये सब लोग को दिखा? ये दोनों वेक्टर जो है, जो ब्लू और ये ऑरेंज वाला वेक्टर है, वो किस प्लेन में है?
एक्स वाई।
हाँ, एक्स वाई प्लेन में है। तो ये बताओ जरा सा कि ए और ये हो गया अपना वेक्टर बी, तो जब ए क्रॉस बी करेंगे तो क्या क्या बनेगा? ए क्रॉस बी करेंगे तो क्या बनेगा भाई? क्रॉस प्रोडक्ट समझते हैं कि नहीं?
हाँ सर।
हाँ, तो क्रॉस प्रोडक्ट करेंगे तो क्या बनेगा बताइए?
सर जेड में कुछ रखा है।
हैं? क्या वो किधर आएगा? Are you getting my screen?
No sir.
नो सर।